Good morning, everyone. Today I would like to present my British Airways data science project. The aim of this project was to predict whether a customer will complete their booking and to explore how predictive analytics can support better marketing decisions. Rather than focusing only on model accuracy, I wanted to understand how the predictions could be translated into practical business actions. I will begin by explaining the business problem, then briefly introduce the data, compare several predictive models, and finally present my business recommendations. Before building any predictive model, we first need to understand the business problem. Every day, thousands of customers start the booking process. However, many leave before completing their reservation. The challenge is that we do not know in advance which customers are still likely to complete their booking and which ones are about to leave. Therefore, the objective of this project is to estimate the probability of booking completion and identify customers who may still respond to a targeted marketing campaign. This allows marketing resources to be focused whether they are most likely to create value, leading to higher booking completion and a better return on marketing investment. The original dataset did not contain separate origin and destination airports. Instead, each flight was stored as a single route using IATA airport codes. Therefore, the first step was feature engineering. I split the route into two new variables, origin airport and destination airport. This allowed us to analyze where journeys started, where they ended, and how booking activity was distributed across the network. Each bubble on the map represents an airport, and the bubble size is proportional to the number of bookings associated with that airport. Then I explored where bookings originated. This map shows the geographical distribution of booking records in the dataset. Darker colors indicate a higher number of bookings. One clear pattern immediately emerged. Most bookings originated from Australia, followed by several countries like Asia-Pacific region. This suggests that the dataset mainly represents customers traveling within this part of the world, rather than a global airline network. Based on the previous findings, I simplified the booking origin country variable before building the predictive models. Countries with fewer than 1,000 booking records were grouped into a single other country category. This reduced the number of categories while preserving the major markets represented in the dataset. As a result, the model became less sensitive to very small groups and could focus on the patterns supported by sufficient data. Before training the models, I examined the distribution of the target variable. The classes were imbalanced. Only around 15% of bookings were completed, while approximately 85% were not. Because of this imbalance, I used stratified data partitioning. This preserved the same class proportions in every subset. The data were divided into the usual three sets: 70% for training, 15% for validation, and 15% for testing. As the charts show, the 85 to 15 class distribution remained almost identical across all three sets. The next step was to reduce the effect of this imbalance during model training by assigning class weights. Because completed bookings are much less common, each completed booking was given more importance during training. This formula simply gives a larger weight to the smaller class and a smaller weight to the larger class. So the model does not mostly learn from incomplete booking. Before comparing predictive models, I used a decision tree to better understand the customer segments in the data. Although the decision tree was not the final model, it clearly shows which factors are most closely associated with booking completion. The first split is based on the customer's country of origin. After that, the model separates customers by their length of stay and for some groups by flight duration. This tells us that both customer location and travel characteristics play an important role in booking behavior. After preparing the data and modeling, I compared several predictive models using an independent test dataset. To compare them fairly, I used ROC area metric. This measures how well a model separates customers who are likely to complete a booking from those who are not, across all possible probability thresholds. This is important because the best probability threshold depends on business priorities and available marketing budget. The Bootstrap Forest achieved the highest ROC area, so it was selected for the final analysis. Up to this point, the model has only estimated the probability that each customer will complete a booking. The business decision comes next. We choose a probability threshold to decide which customers should receive additional marketing. A lower threshold targets more customers but increases marketing costs. A higher threshold reduces costs but may miss customers who could still be persuaded to book. For this reason, there is no single correct threshold. It should be selected according to the campaign objective, the available budget, and the expected return on investment. Now, let's see how those probabilities can be used in practice. Customers with a high probability are already likely to complete their booking, so they usually do not require additional marketing. Customers with a very low probability are less likely to respond, so expensive campaigns may not be worthwhile. The greatest opportunity is the middle group. These customers are still undecided, making them the best target for personalized marketing. The exact probability thresholds should be chosen according to the campaign cost, available budget, and the expected return on investment. To conclude, this project shows that predictive analytics can support practical marketing decisions. Rather than treating all customers in the same way, British Airways can focus marketing on customers who are still deciding whether to complete their booking. By adjusting the probability threshold to campaign costs and expected return, the company can improve marketing efficiency and maximize business value. Thank you for your attention.